In this project, we predicted the prices of used cars using machine learning algorithms. 3 datasets from 3 countries were used. From the USA, a Craigslist dataset was used, which was acquired from Kaggle. For Germany, an eBay Kleinanzeigen dataset was used, which was also acquired from Kaggle. And finally, for Ireland, a Donedeal.ie dataset was used, which was scraped for the purposes of this project. We will examine the American dataset in detail for the purposes of this video, following it through from data preparation to hyperparameter tuning to finally the production of some results from our machine learning algorithm. We will finally evaluate what these results lead to. The Craigslist dataset consisted of 25 features and over 500,000 records. Now, there were some issues with data quality here, particularly around missing values, which is to be expected when people are posting ads themselves online, as well as some redundant features that would be unlikely to be much use in a machine learning model. It was decided to impute values for some of these categorical variables like cylinders and also type of car where they were missing based off the manufacturer and model fields. And this had some success, but in other cases it was decided to remove records entirely based off data quality issues. Individual data cleaning scripts were prepared for all 3 datasets. In these, data was read in, outliers were removed on miles and price based off a 2 times the interquartile range logic. Some unwanted values at extremes were removed. Manufacturers where there was less than 100 of a car sold were removed. The same with models where there was less than 50. There was the dropping of duplicates based off a number of fields, followed by the actual removal of unwanted features. Then there was the imputing of data based off the mean for cylinders and based off the first available for variables drive and type. When this script is run, it produces a file which is then read in by the machine learning algorithms which follow this script. Machine learning algorithms were initially run without hyperparameter tuning. However, after further research, it was decided that any opportunity to improve accuracy of these algorithms should be taken. So here we see the hyperparameter tuning taking place of the American dataset for a gradient boost algorithm. So we've made a bunch of parameters to be run. We're running a grid search. And we see that at the moment it is in the process of running. It tends to be quite time intensive, but at the end we will come up with the most accurate parameters that can be used to optimize accuracy in the model. This script is running at the moment and will take quite a long time to complete all in all. The US dataset is quite large, so I wouldn't expect this to be finished for 90 minutes minimum. Here is our machine learning script, which will execute our 5 machine learning methods on the US data, which we will use as an example here. In this script, we use both one-hot encoding and we use label encoding, depending on what type of algorithm is used. It has been shown that using one-hot encoding, for example, can have quite negative effects on a random forest regressor, and it can make it take a very long amount of time. So to speed up the process a bit, we went for both. So there were 5 machine learning algorithms used after the data was split out into training and test sets at an 80-20 ratio. Firstly, there was linear regression, followed by random forest regression, followed by artificial neural network regression, then followed by extreme gradient boosting regression, and finally, using an ensemble technique, a bagging regressor. And when all this is done, we will compare the data that has been held out, the actual values, compared to the real values for all 5, and the results of all 5 will be used for checking the error in the model. This script is running at the moment and will take quite a long time to complete all in all. The US dataset is quite large, so I wouldn't expect this to be finished for 90 minutes minimum. When our 5 machine learning algorithms had finished, we examined the root mean squared error of the predictions of each of these using the train test split that we used. So looking at the case of the US dataset, we see that the random forest performed best. This is actually different to how both the Irish and German datasets performed, where XGBoost performed marginally better than random forest. When we take a deeper dive into the results of the machine learning algorithms and examine the results when the prices are grouped into tiers of $4,000 each, we see a clear trend emerges. At lower prices, there is a much higher relative percentage error. And of course, this would be expected to a degree because, say, if you have a car that actually costs $400 and you predict it to be $600, it's a 50% error automatically. While as the prices get a bit higher, this sort of error won't be seen. However, it is still clear to see that the middle-priced cars do perform best and can be predicted the best. And as prices get higher, which you would expect to be the inverse of the effect you see with the smaller prices, the accuracy tends to get worse again. And this is looking at random forest. We have it here for all of them. When we look at the root mean squared error of all of the algorithms on all of the countries, there is a clear trend. Artificial neural networks perform the worst, quite similarly to linear regression, and random forest, extreme gradient boosting, and bagging tend to perform quite similarly and relatively well. All in all, this project was an interesting exploration in the potential of using machine learning algorithms to predict the prices of used cars and in other purposes too.